The EU's AI Act is a fascinating piece of legislation because it grapples with the core dilemma: how do you regulate the artificial intelligence we have right now while also preparing for the much more powerful and perhaps unpredictable systems of the future? We're going to explore its really elegant two-part strategy for doing just that.
So here's the central question legislators had to answer. For a long time, the debate was really dominated by this idea of artificial general intelligence, or AGI. But from a legal standpoint, you can't attach clear enforceable obligations to something that's still hypothetical. The true genius of the AI Act is in how it very strategically sidesteps this problem.
To see how they did it, we'll follow the Act's own logic. We'll start with its deliberate pivot away from these hypothetical ideas, then break down how it regulates today's AI. After that, we'll look at its plan for tomorrow's systems, see the strategy in action, and finish with its core principles of pragmatism and preparedness.
When you read the final text of the Act, one of the first things that strikes you is what's missing. You won't find terms like AGI or human-level intelligence. And that wasn't an oversight. It was a very deliberate choice, made to ground the law in the tangible technology that's already out in the world making an impact. You see, the original 2021 draft had a pretty big flaw. It tried to tie risk to a system's intended purpose. But a foundational model, something like a GPT-4, doesn't have just one purpose. It's more like a raw material. This created a huge liability gap. If a defect in that core model caused harm in some downstream high-risk application, say in healthcare or finance, who was actually responsible? The solution was to introduce an entirely new chapter, Title V. And this was a critical maneuver. It created a fresh set of rules that applied directly to the provider of the foundational model itself. And crucially, this happens before it's integrated into any other product. This very cleverly legally stitches the entire value chain together, making sure that responsibility is shared fairly, right from the very top. Now, what's really quite brilliant here is how the Act's solution hinges on precise legal definitions. These aren't just abstract philosophical statements. They are incredibly practical tools for assigning responsibility to different actors all along that value chain. First up, the Act defines the GPAI model. The best way to think of this is as the core engine. It's that powerful general-purpose technical component, like a GPT-4 or Claude 3, that can then be built upon and integrated into all sorts of other systems. And then it separately defines the GPAI system. So if the model is the engine, the system is the finished vehicle that actually uses that engine. It's the model plus any other components, like a user interface, that turns it into a product that serves an end user. And this distinction is absolutely central to the whole strategy. By splitting the definitions, the Act can assign very different and very specific responsibilities. The provider of the model has upstream duties to its customers, the developers who use it, and the provider of the system, in turn, has downstream duties, like transparency, to its end users. This very clear separation of responsibilities leads to a pragmatic, two-tiered framework of obligations, which you can think of as a duplex of duties. Think of it like this. On the ground floor, all providers of GPAI models have some baseline duties that are mostly about transparency, things like providing good technical documentation and a summary of their training data. But on the penthouse level, for models that are deemed to pose a systemic risk, a much higher, much more intensive tier of obligations kicks in. This includes things like mandatory model evaluations, risk assessments, and reporting serious incidents. So that's how the Act handles the AI of today. But this framework is also designed to be future-proof. And this is where we really start to see how it prepares for the hypothetical. The Act uses a very clever two-part test to figure out if a model is systemic and therefore has to follow those tougher rules. You can think of this dual gateway system as a filter designed to catch unforeseen capabilities. The first gateway is a simple number, a quantitative threshold. Any model that's trained using an enormous amount of computing power, more than 10 to the 25th floating point operations, or flops, is automatically presumed to be systemic. Now, this gives you some objective clarity, but it's what we'd call a brittle metric. It's using computational cost as a proxy for risk, and we all know that advances in efficiency can make it outdated fairly quickly. And that is precisely why the second gateway is so important. It's a durable safety net. This gives the European Commission the power to designate a model as systemic based on its actual demonstrated capabilities and its market reach, completely regardless of the compute used to train it.
This right here is the true future-proofing mechanism. It's designed to catch those powerful yet highly efficient models that might fly under the flop's radar. This is all supported by an adaptive governance structure. You have a central AI office that acts as the regulator. You have an independent scientific panel that serves as the technical brain, spotting emerging risks. And, very importantly, the commission has the power to issue delegated acts. These are essentially fast-track updates that allow them to change technical rules, like that flops threshold, without having to go through years of new legislation. And this framework isn't just a theory on paper. Recent developments in 2025 are already confirming just how this two-part strategy, regulating the actual while preparing for the hypothetical, is working in practice. On one hand, a new code of practice finalized in July 2025 focuses on today's practical problems, things like copyright compliance and documentation standards. That's dealing with the actual. But at the very same time, new scientific reports are already paving the way to replace that brittle flops metric with a more robust basket of benchmarks that can directly measure a model's capabilities. This is the adaptive system working exactly as it was designed to. So, as we wrap this up, the key takeaway is that the Act's profound strength lies not only in what it does, but in what it very deliberately chooses not to do. It completely avoids the trap of trying to regulate a vague and unknowable future. Instead, what it does is execute this elegant two-part strategy. First, it regulates the actual technology that we have right now, solving the immediate problems of liability and transparency for general-purpose AI. And second, it builds the institutional agility to prepare for any hypothetical high-impact technology of tomorrow using that durable capability filter and its adaptive governance system. Ultimately, the EU AI Act doesn't try to regulate AGI. It accomplishes something far more practical, and I would argue far more powerful. It regulates general-purpose technology today, while at the same time building the institutional agility to regulate high-impact technology, whatever that may be, long into the future. It has created a model for agile governance that addresses the very real risks of the present, while building the resilience to manage the challenges that are yet to come.